Page 2 of our probability practice starts with another Venn diagram question. This time we have a 3 Venn diagram. So we got 2 classes with a total of 45 students were surveyed to indicate their pet preferences. Their choices were cats, dogs, or birds. So I'm going to label my circles C for cats, D for dogs, and B for birds. We were told, so then we're going to go through and do some probability. So we were told 10 students liked cats and dogs, but not birds. So cats and dogs, so we're looking in that overlap here, but not in the bird circle. So that would be just this space up top here. So that would be 10 that goes in there. And I don't have to do any subtraction, just straight up 10. All right, students who like dogs and birds, but not cats. So again, we're looking in the overlap, but we want to take out the cat circle. So we erase the cat circle, which means we're just focused on the overlap between dogs and birds. All right, 12 students liked cats and birds. That's not going to help me yet. 18 students liked cats and dogs. Ooh, that's a helpful one. So this space right here that I've highlighted in blue should total up to 18. Well, I already have 10, which means in the middle here, I would need 8. And so I'm going to fill in an 8 right there. And once I have that, I can now go back and do the space above because that one said 12 students like cats and birds. Well, if I already have 8 in this space, then I would need 4 more to get my overlap to total 12. And I'm sort of just moving right along. So then I have 28 students that liked cats only. So if I notice so far in my cat group, I have 4 plus 8 plus 10, which is 22. So 28 minus 22 would get me 6 that should go in the cats only category. And I'm going to treat basically all of these sort of similarly. So with dogs, I have 2 plus 8 plus 10, which is 20. And 25 minus 20 is 5. And last but not least, with the birds, 8 plus 2 is 10, plus 4 is 14, which leaves one person who likes birds only. Now, we need to go back and make sure that we have all of our students covered because remember, there are 45 total students. And so you do this by just sort of adding up all the numbers we have here. So we have 6 plus 10 plus 5 plus 4 plus 8 plus 2 plus 1. So 16 plus 5 is 21, plus 4 is 25, plus 8 is 33, plus 2 is 35, plus 1 is 36. 45 minus 36 leaves us with 9 who don't really like any type of those types of pets. So we've created our Venn diagram. Now we're going to use our Venn diagram to answer some probability questions. Now, in this case, we have our probability questions written out as sentences. So one of the things we're going to practice doing is sort of rewriting this into probability notation, then also our answer, just so we sort of can interpret back and forth between the two. So we have, what is the probability that a student selected at random prefers cats only? So I would label this cats only. And if I go to my Venn diagram, I'm looking for a value just in the cat circle and nothing else. And so that's 6 right there out of my total of 45, which would be 13.3%. All right, next up we have, what is the probability that a student selected at random prefers cats and dogs? They couldn't make up their mind. So cats and dogs. That would be, this is an example of overlap and. So we're going to be focused on the overlap here, which would be the 10 and the 8 between the cats and the dogs, which was 18 out of the 45. And that comes out to 40%. All right, next up, what is the probability that a student selected prefers cats or dogs? And this is overlapping because if I focus on my cat circle, I go here. But then if I focus on my dog circle, and they do share the 10 and the 8, so you need to be careful. When it comes to Venn diagrams, I do find it easier to just straight up add the numbers or subtract. Notice all the values are highlighted except the 1 and the 9. So there are 10 people not in this group. So it might be easier to go that way. If there are 10 people not in the group and there's 45 total, that means that there'd be 35 that I highlighted. The other option would be, of course, to just add up all the numbers. 35 out of 45 is 77.8%. All right, next up, probability that a student who prefers cats also prefers dogs. So in this setup, the sort of given is that the person likes cats. And we want to know how many of them also prefer dogs. Well, so let's start with the blue we highlighted are the people who like cats. Remember, 28 students liked cats. And of those 28, the yellow-blue overlap, those are the people who like cats and dogs. So the 18 who liked both. And that would be 64.3%. The next one's going to be the sort of opposite situation. What is the probability that a student prefers cats given they prefer dogs? So if we focus up here, the yellow highlighted circle, there are 25 students in that yellow highlighted circle. And of those 25, 18 like both cats and dogs, which ends up being 72%. And so we got some probabilities based off of our Venn diagram. Next up, we're going to take another look at a contingency table. This particular contingency table only gave us the total down here, but didn't give us the total overall. One thing you might find helpful is to sort of go through and do some totals so that you have them. Not necessary. I sort of did the totals as I needed them. It's sort of up to you. In this case, the total male plus the total female does come out to 2885381. So that's 2,885,381. Also looking ahead, I'm going to want the 20 to 44 total. And that one oh, no, I'm not. Never mind. I'm not reading. I need to read more carefully. Sorry about that. Let's ignore what other totals I need. I need just the total for now. All right, step 1. What is the probability of selecting someone from this COVID dashboard data that was male? Well, there are 1,320,084 males. Out of the 2,885,381 people. And if you put that in a calculator, that would come out to 45.8%. Probability for B, 20 to 44-year-old female. So that's an and. That's an overlap and probability. So 22 to 44-year-old and female would be this number right here. And so my probability would be 443,804 out of 2,885,381, which is about 15.4%. Next one is an OR. So remember, with ORs, we're looking at like the total. So we have female, so that's everything in this column, and 65 and older. So that's everything over here. So yes, I can do totals, or what I find easier is I just took the total number of females. I'm going to erase my other greens for right now so you're not confused. So I just took my total females, and then I added it to the males who are 65 and older. And that would cover then all those groups of people. That would be female or 65 years and older. And so that comes out to 2,027,201 out of the 2,885,381, which is 70.3%. The next page is just another one where we're sort of reading our contingency table and then coming up with some probabilities. So part of this, I just want to make sure we're sort of interpreting our questions correctly and understanding what's being asked. So here we have, what is the probability that a person is from the United States? So probability that someone's from the U.S. In this case, I would go all the way over to my total U.S. column. That's 1,557 out of that 7,690 on this table, which is 20.2%. The next, probability that a person has completed his or her education before college. So if we're thinking about before college, that's all of these columns. Well, not the no answer column. We don't really know what those are, but it's high school or primary school or less. So we're basically totaling up those two numbers. And so probability complete ed before college. You know, sometimes you really can't shorten it with abbreviations, so you sort of have to write out like a mini sentence, and that's okay. And if I totaled those numbers, I would get 5,356 out of those 7,690, which is 69.6% of the people who were surveyed here. Next question. What is the probability that a person is from France or did some postgraduate study? All right, so from France would be everyone in this row. And then did some postgraduate study would be everyone in this column. So this is one of those where we have enough numbers that I find it helpful to maybe add totals and then subtract out the overlap so we don't count it twice. So in this case, so the probability of France or post-grad. And so we'd have 379 plus 1,539. But we want to make sure we minus out that 69 overlap. And that's out of still the 7,690. And so that would total 1,849 out of 7,690, which is about 24%. All right, probability. Now we're looking at an overlap. We have the probability that someone is from France and finished only primary school or less. All right, so now we want the overlap. So we're still focused on that France column, but we're looking at a different number this time. This time we want the number that is primary school or less, which is the 309. So that would be 309, still out of the 7,690, which would end up being 4%. Next problem. So we have the probability, given that the respondent is a postgraduate, what is the probability that they're from the United States? So we have the probability that someone's from the U.S. given that they have postgrad. So we're going to be focused on the total from the postgrad column and then how many are from the United States? So our total is the 379, and US, that's 84. And so that gives us a percentage of 22.2%. Given the respondents from the UK, what's the probability that she has a high school diploma? So probability, UK, high school diploma. All right, so I need the UK row. And so the UK row would be all of this. And so that's 1,557, but has a high school diploma. Now that's tricky because the reality is it's not just these people who graduated from high school, but it's also the people who went to college and the people who have postgraduate. So I would actually end up adding all three of those numbers, which would get me 1,505 out of the 1,557 that are from the UK. And so 96.7% of the respondents from the UK also have at least a high school diploma. All right, what is the probability that a respondent who only has a primary level education is from China? So what's the probability someone's from China given they have only a primary level education? So we're focused on the primary level education this time. That would be this column. So the 1,161. And 506 of those are from China. So 1,161, the 506 from China, that's 43.6%. All right, the last one on this one. So we have what is the probability that a respondent from China only has a primary level education? So that's basically the reverse of Part G. So only primary, given they're from China. So the number of people from China in this survey was 1,502. And of those 1,502, 506 only had a primary level education. And so that would be about 33.7% of the people surveyed.